Hello, good morning.
Morning, sir.
Yeah. So yesterday we understood the implementation till the radic short. Now we have to understand the implementation part for the address calculation short, and then yesterday you also understood the linear search and binary search. So we will see the implementation of the linear as well as the binary search also. So now I have one more example on this address calculation sorting. So these are the number of elements taken: 28, 43, 55, 14, 88, 39, 91, 33, 49. Now here we are applying the hash function and finding the digit in the higher position or the highest place. So we are finding the digit in the highest place. Now these are the digits. For 28 you are getting it as 2 when you apply the hash function. 4, 5, this, and then this is what so usually we build the number of list from 0 to 9, okay, and based on the result of the hash function, we go for assigning the element into the corresponding list. Okay, so now 14 is assigned to the list with the key 1 because the result of the hash function is 1. Okay, and similarly, if there are more than one node which should be attached to the same list, so we do the comparison and we go for performing either insert at the front or the rear or insert in the middle, depending on the sequence of elements what we have. So now this is the implementation part for it. So let us start from the main. So these are all the header files. I'll just go to the main function. Yeah, so this is the main what you are seeing. So I'm reading the total number of elements here. The number of elements are read to n, variable n, and then reading all the elements of the array and then making a call to address calculate. Okay, I'm passing the array and I'm also passing the total number of elements. Now address calculation is here. Now what I'm doing in address calculation, see, first here I'm running a for loop and then I'm finding the quotient. Okay, so by calling function of array of 1, I take each of the element, I just pass it as an argument to array of 5, and then I'm finding the position. Okay, so you can find the position by using this n modulus n by 10. N by 10 gives you the quotient. Okay, so you take the quotient, that gives you the position where this is, you can say, the hash function what we are doing. Okay, so where the element should be inserted in the list, or which list the element should go. So this is what we are finding here. The position will get this value, hash function value what we understood here. So this is this value gets assigned to the position. Next, what we do after it gets assigned to position, now I call the function insert. To that I'm passing head of position and then the array element also. Okay, and we'll go to the insert function, and the insert, when I go, it is the normal function. Okay, as we have already understood for inserting to the singly linked list. So you know how to insert to the singly linked list at the beginning, end, okay, and also in the middle. So hope you understood here.
Yes, sir.
Yeah, what this is doing, so when I call function of array of 5 by passing the first element, this is the function that is called. So you can see the definition of fen here. Okay, return n by 10. What you are returning is the quotient, and that quotient gives you the position where the or which list the element should be inserted. I just go up to the insert function now. So this is what you're seeing as the insert function. So this insert function is same as the insert function which you understood, and this is having all of them. We have inserting at the beginning, inserting at the middle, and inserting at the rear, depending on the situation. Now what we do, so we come to the insert part here. So starting node is passed and the element to be inserted is also passed. So I create the node. So node because memory you have to allocate, okay, for the info field and the link field. So get node. So this is the function. This is going to allocate the required memory for creating the node, and then after the memory is allocated, we assign the number to the data field, and the next field we are making it as null. And here what I do, so if start is equal to null, so that itself is the first node. The node which we inserted itself is the first node. So otherwise, if it is not the first node, some node already existing in the list, so then what I do, I go for the else part. So a new node is placed at the appropriate position in the subfile. Now how to place it the appropriate position? So I have to go for comparing the data field of the temp node with the num. Okay, so temp arrow next arrow data is less than or equal to num, and temp arrow next not equal to null. Now what I do, this is where I insert, and again similarly, if the data field of the new node is less than the data field of the temp node, so then this is what I do. So that means you got to perform the insert at the beginning, okay, because start is made as new. Otherwise, so if the data field, okay, is not less, okay, and so this is for the traversing, okay, so we keep traversing till we find the node where we got to insert, and here we insert. If the data field of the new node is less than the data field of the temp node, we insert it at the beginning. Otherwise you go for inserting at the rear end, okay, and then what we do, we return the start. So no question of inserting and then we are going to return the start, okay, because this is going to find you the appropriate position, okay, where the element should be inserted. We keep traversing the existing list until these two conditions are satisfied. As long as temp arrow next arrow data less than or equal to num, we make the temp to travel and point to the next node, and after that we go for comparing the data field of the new node with the data field which is available in the temp node. If this matches, so you go to insert it before that node, otherwise it has to be inserted after that node. So this is what is the insert node, okay. And next is, after you insert, how many times you do this? You're going to do this for this many times. So because this you're running inside the for loop, you take every element, find the position, and then go for appropriately inserting it to the subfile or the sublist. And after you insert everything to the subfile or the sublist, so once this loop terminates, so you come here, run one more for loop. So next thing what you are doing is merging all the subfiles into one list, okay. So or in other words, you are taking everything from the subfile and adding it into the another array, this one ARR, okay. So I take I is equal to 0, I less than 10, I plus plus. I check head of I not equal to null, so I access the data field of it and I'm assigning it to array of j. J is already initialized to 0, so j plus plus, and then I increment the head, okay. So this process we repeat until it is equal to null from the beginning till the end, and the same thing is repeated for all the subfiles or the sublist. And finally, when all the subfiles are traversed, so we have the shorted array in array of j plus plus. Hope you people understood this part. Is it clear?
Yes, sir.
Okay. And then the shorted elements we are printing, okay. So this is what is the address calculation sort is. Next we'll go for discussing the implementation part of searching techniques. Yeah, yesterday we completed this radix sort. No. Okay, so first we'll understand how the linear search works. Now here I've declared an array of size 100 and a variable with the name search, because I'm going to read the search element to this. So C is another variable, N is for reading the number of elements. So I'm enter the number of elements, I'm reading the number of elements to N. Okay, and then I'm just prompting on the screen saying enter so many integers. Now using a for loop, I'm reading all the integers, so many integers from the keyboard, and storing them into another array with the name array itself. Name of the array is array itself, and C is taken as the variable for the for loop. Okay, then reading the search key to the variable search. Now again we are running, since this is a linear search, so we run a for loop. Okay, so for C is equal to 0, C less than and C plus plus, so I access every element of the array and I'll be comparing sequentially with the search key. So if it is equal, I say the element is found and it is present in the array, and also go for displaying the location or the position where it is found. So in the print list, what you have is search. So this %d is the format specifier for printing, or the placeholder for printing the result of search, and this %d is the placeholder for printing the result of the position, or when you are printing the position, it has to be C plus 1. Why C plus 1? Because we are starting the index from 0. Okay, so you got to increment it by 1. So if the element is at position 3, so while printing you have to print it as element is at position 4. And once it is found, say for example you have started searching, the first element itself is your search key, you print this, and it is not necessary for you to continue with the remaining searching with the remaining items of the array. So you got to terminate the execution of the loop. Okay, so you are calling break. In case if the required element is not found, okay, so this condition will not be true and it will not come here, and it's going to cover all the iterations of the for loop. So once it is done, so we are here, and I say if C is equal to N, so the value of C, which is the index of the array, if it is equal to N, what does it mean? So we have crossed through the index of the array and we have not found the element. Okay, element is not there in the array. Or otherwise you can also go for taking a flag variable, say something like this, int flag is equal to 0. Initially you initialize it to 0, and here if the element is found, if this condition is true, just make flag is equal to 1. Flag is equal to 1, and then print the element and break the loop. And here you can go for, instead of saying C is equal to N, now what we are basically comparing here in this example is we are comparing the index value of the array, or the final C value, with the N value. If it is equal, we say the element is not present in the array. So if you don't want to do this way, you can also go for doing it by using the flag variable. So I want this message to be printed only if the flag is 0. If flag is equal to 0, so then I print this. Okay, if the flag is not 0, then I go for, if flag is not 0, so that means what? The element is found, and this is what the printf statement that gets executed and printed on the screen. OP people understood? Okay. So next is the binary search program. Again here, so we have taken C again for the looping purpose, first, last, middle. So I make the first to point to the lower index of the array, and last to point to the higher index of the array, and middle is made to point to the middle index of the array. N is the total for reading the number of elements, and search is the search key, the element which I need to find, and this is the array what I am taking. Okay, now enter the number of elements. Again, the total number of elements required, I am reading it into n, and enter so many integers. Okay, and along with this enter so many integers, you can also go for displaying enter so many integers in shorted manner. Okay, because binary search, the input condition is always you have to go for giving the input the shorted array, either shorted in ascending order or descending order. Okay, so if you want, you can go for updating this. Okay, so enter so many integers, you call the for loop and read them, and the integers are stored into array of 0. And next, so read the element which you want to look for or the search for. Okay, enter the value to find, and I'm reading it into search. Next thing what we are doing is, this is important. So first you got to make the first pointer show, you got to make it to point to the lower index of the array, and the lower index of the array we are starting from what? 0. C is equal to 0. You can observe this for loop. So since we are starting this for loop from C is equal to 0, the lower index of the array will be what? 0. So first is equal to 0, and similarly the higher index of the array will be what? N minus 1, since we are starting from 0. So if you are starting the loop from 1, so the lower index of the array will be 1, and the last higher index of the array will be equal to n. But since in this case, since we are starting the loop from 0, first is equal to 0 and last is equal to n minus 1. So after you initialize the lower index and the higher index of the array, next is finding the middle element. Now to find the middle element, you got to sum the low plus last divided by 2. Say for example, I have 1, 2, 3. These are my elements, array elements. I am taking the shorted elements itself. 5, 6. Okay, enough. And these are my array elements. And let me write the indexes of those things above. So this is 0 at the 0th index of the array, and this is at the first index of the array, and this is stored at the second index of the array, and this is stored at the third index of the array, and this is at the fourth, and this is at the fifth. And we have made right now first to point to this, and we made last to point to this. Last is pointing to this. You can just observe here. So last is equal to n. Total number of elements here are 6. 6 minus 1 is 5. So last is pointing to the lower index of the array. Now when I say first plus last by 2, so first is 0 plus 5, last is 5, so divided by 2, so this is equal to 4. Okay, so since it is integer division, so fraction 4.5, not 4, 2. Okay, 2.5 you cannot take. So since it is an integer division, the result of this operation is 2. Now middle will become 2. That means middle goes and points to the array index 2. Okay, middle is pointing to the 2 now. Next what we do, we go for comparing first and last. Remember, the statements which are there inside the while, they got to be executed as long as first is less than or equal to last. The moment the first crosses or the low in the previous day when we were discussing the example, I took it as low, but here I've considered it as first. So the moment the first crosses the last, so you have to stop the process. What does it mean? If first crosses last, the element is not found, and you have checked all the elements within the array, and the element which you're looking for is not found inside the array. So this is the condition for terminating the while loop. Okay, so while first is less than or equal to last, so while first is less than or equal to last, the now condition is true. First is 0 and last is 5. 0 less than or equal to 5, it is true. Now we go into the while loop and we check the condition. So what is that we are doing now? Say search key, I am interested in finding the element, let me take 6. So my search key is 6. Okay, this is what I'm trying to find now. Now I'm just checking if array of middle less than search key is 6, this is 6, and array of middle is 3. So 3 is less than 6, it is true. Now what you have to do? So you have to search your element in the right half of the array. So since your search key is greater than 3, so the element has to be found in this right half of the array. Now the last pointer you are not going to modify, only the first pointer should be modified in case if the search key is greater than the mid element. Now what is that I do now? Now first is equal to mid plus 1. So first was initially 0, now first I am making it as 2 plus 1. So when I make 2 plus 1, so first is pointing to the fourth element, or first holds the index of the fourth element. That is what we are doing here. First is equal to mid plus 1. Hope you people understood till here. Okay. Now here, now we don't have the first pointing here. So first is pointing to 3. Let me write it as only f. So first is pointing to this. Next what we do? So else if, this is the other condition, in case if the middle is not less than the search, next what we do? Here in the else part, okay, if it is equal, we say it is found and print the position also and break the loop. If it is not equal, so the other thing, if it is not less than, what does it mean? It is greater than, so then last should be modified. Last is equal to middle minus 1. Okay, first we retain at the same position and the last pointer we modify. Okay, now this is also not true and it will not also go to this else part since this condition is true. Now again we come here and find the middle. Okay, so I have to find the mid of this array right now. So mid of this, so f is pointing to 3, first is pointing to 3 and last is pointing to 5. Now it is 3 plus 5 by 2. Now the new mid what I am getting is 4. So 8 by 2, 4. So now middle is not pointing to 2, so middle is pointing to 4 right now. I'll write it as middle, I'll write it as m. So this is first, this is middle, and this is last right now. And then I go back to the while loop and again I check whether first is less than or equal to last. So what is first? First is 3 and last is 5. 3 is less than or equal to 5, condition is true. Next I come here, I compare the array of middle. So array of middle is right now 5. Okay, only middle is 4 and array of middle is 5. So 5 less than search key is 6, 5 less than 6. Again it is true. Now which pointer I have to, which index I need to modify? The first index. Okay, so first is again made as middle plus 1. Okay, so previous first value, middle value is 4 and the previous first value was 3. Now the first becomes what? 4. Sorry, 4 plus 1, 5. I'll erase this. So first is not pointing to this. Now first is pointing to 5. Okay, it is 4 plus 1. Now again so since this condition is true now, okay, okay, I come to this position now. Now I check, again the new middle is equal to, let me erase all these things. New middle we are finding, so new middle is again first and last. See, they are pointing to the same. Okay, first and last are pointing to the same. First is also 5 and last is also 5 divided by 2, and the result what you are getting is also 5. So new middle is 5. Now middle is no longer pointing to this 4. Now middle is also pointing to 5. So middle is pointing to this. Now go back again to the while loop. Check whether first is less than or equal to last. So first is also 5, last is also 5. Okay, so last is not 6 index. When I say first and last, they are the indexes. So first is also 5, last is also 5, 5 less than or equal to 5, true. And now here I check whether array of middle, that is array of 5, that is 6, less than 6, 6 less than 6, false it is. Now it will come to the else if part. Now we are checking array of 6 is equal to search. So array of 5 is equal to search, 6 is equal to 6. Now what has happened? So the element is found. So we print this message. So 6 is found at location, it says 6. Instead of middle value is right now 5. Instead of saying it as 5, we say it is found at the location or 6. So 5 plus 1, and then we break the while loop and come out. Okay, and here we check. So if first is greater than last, okay, so first is what? 5 and last is also 5. So that means this condition is not true and this statement will not be executed. Okay, so now, so this is what you understood for the searching the element which is there in the right half of the array. Now similarly we will see how it works if the search key which you are trying to find is in the left half of the array. Okay, let me erase all these things. Is it clear till here? Okay. So we will try to find the element which is there in the left half of the array, and after that, so how it works if the element is not there. Okay, this is my array again. Array I'm not going to change. I'll make first to point to this. First I'll write it as F. I'll make last to instead of writing here, let me write above. So first is this and last value is 5. I'll take search key as, I'll write here. So we search for 6, now we'll search for 1. Okay, this one. Now what I do? So this is done. First is done, last is done. Now middle I have to find. Now when I'm finding the middle, it is m is equal to, so 0 plus 5 by 2, that is nothing but 2. So middle is pointing to 2. Okay, now I check while first is less than or equal to last. Yes, 0 less than or equal to 5, true. I enter. I go for comparing my search element 1 with the element which is found in the middle. Okay, so array of middle, that is 3 less than 1. So search key is 1, 3 less than 1, condition is false. That means, so the element which I am finding now, it is not there in the right half of the array, but it is present in the left half of the array. Okay, now I don't go for modifying the first pointer. Now else if I check whether they are same, they are equal, so they are also not equal. This is 3 and this is 1. Now I come to the else part, I modify the last pointer. Okay, last was pointing to this. Now I say last is equal to mid minus 1. So mid is 2, mid minus 1 is 2 minus 1 is 1. I'll erase this. Now last is pointing to 1. So last is pointing to this. That I have to focus on this subarray for finding the element. Next again, I go for finding the new middle. So new middle is equal to, it is 0 plus 1 divided by 2. Now 1 by 2. Okay, I cannot write it as 0.5. It is 0. Okay, 0. That means the middle, now it is not pointing to 2, it goes and points to 0. Same is pointing to this. Next, I go back to the while loop again. I check whether first is less than or equal to last. Yes, it is true. So first is 0 and last is 1. 0 less than or equal to 1. Now I check if array of middle, okay, array of middle less than search. So array of middle is what? 1. 1 is less than 1. False it is. Now it will not go to this case, and it comes to the else if part. Array of 1, array of middle, 1 equal to 1. It is true, and it says 1 is found at so and so location. Okay, so 1 is found at the position. Instead of saying it as 0, it will say it is found at the position 1. Okay, and then we come here and we check whether first is greater than last. So first is 0 and last is 1. So condition is not true, and this message will not be printed. Okay, this is, you understood how it finds the element in the left subarray, and how it finds the element in the right subarray, and how the last pointer gets modified, and how the first, when the first pointer is going to get modified. So now we'll see how it works if the element which you are looking for is not there in the array. Okay, again I take first pointing to this, last pointing to this, last is pointing to this, and now, so search key, I'll take it as 7. So 7 is not in the array. Okay, so I'll find the middle. So obviously middle, when I do 0 plus 5 by 2, I get the middle as 2. So m is equal to 2. So middle is pointing to this. I check first is less than or equal to last. 0 is less than or equal to 5, true. I go for comparing array of middle with the search. Array of middle is 3. 3, okay, less than search key. So since the middle element is less than the search key, so now I understood the element which I am looking for is present in the right half of the array. Now I go for modifying the first pointer. First is equal to mid plus 1. The first gets updated. So mid plus 1 is this. First is pointing to 3. Okay. Now since this condition was true, it will not go here and it will not go to this also, and now it will go for finding the new middle. So new middle is 3 plus 5, 8 by 2, that is 4. New middle is 4. Now middle is not pointing to this 2 right now, so new middle is 4. Middle is pointing to this. Now again I go back to the while, I check whether first is less than last, less than or equal to last. So 3 less than or equal to 5. Condition is true. Okay. Now what we do? So I again check if array of middle less than search. Array of middle is 5. 5 less than 7. Okay. True it is. So once again I have to go for modifying the first pointer. Now first again it will be made as first is equal to mid plus 1. Now first is not pointing to 3 now, so first also goes and points to L. Mid plus 1, 4 plus 1, 5. First also points to the same index where last is pointing. First also points to first and last, both of them are pointing to this. Now since this condition was true, so it will not go to the else if part and it will not also go to the else part. Now it directly comes to the middle and it finds the new middle. So new middle is equal to 5 plus 5. So first is also 5, last is also 5. 5 plus 5 by 2. So new middle is 5. Now middle is not pointing to this. So middle also pointing to this 5. See, all three index have the same value now. So F also the same index value, L also the same index value, M also the same index value. Next I go back to the while. I compare here. First is less than or equal to last. Yes, first and last, they are equal. So when again the condition is true, we are into the while and I check if array of middle is how much? 6 less than search key 7. Again this is true. Again this condition is true. Again we go for modifying the first. So first is updated now. First is equal to mid plus 1. What is the mid value? 5. So first becomes 6 now. So which is outside the boundary of what? The array. Okay. Outside the range of the array. So now first is not pointing to 5. So first will become, let me write here. First is equal to 6. Okay. So this 6, index 6 is outside the range of my array. Okay. So first is 6. Now this is also not true and this is also not true. Since this condition is true, first is updated and it will not go here, it will not go here. Again it will try to find the new middle. Okay. So middle is equal to, so new middle is the 6 plus 5. Okay. 11 it is, by 2 is, again what you are getting is 5. So middle is pointing here itself. Okay. To 5 itself. So we go back to the while. We compare now. First is less than or equal to last. Okay. Now first is how much now? 6. 6 less than or equal to 5. Condition is false. Now we come out of this while loop. The while loop terminates. And here I am checking first is greater than last. Yes. First is greater than last. 6 is greater than 5. And I say not found. Say not found. Hope you understood. Okay. So this is what is the binary search. So we have completed till now the sorting techniques. Okay, around 7 sorting techniques and 2 searching techniques. And what the next topic is, so hashing techniques. Okay, and you have one lab program on the hashing technique. Okay, so we'll stop here, and hashing technique, and only two topics remaining: hashing technique and then the files. So from Monday we'll start the hashing technique, and Tuesday probably I'll be giving you the 12th lab program, the last lab program. Okay, and by Saturday I'll manage to complete this entire 5th module. So next week Saturday I'll try to complete the whole thing, entire thing. So let me finish taking the attendance.